What if humanity's return to the moon wasn't just a one-time event, but the beginning of a permanent presence? What if the next giant leap wasn't just about flags and footprints, but factories and families? SpaceX believes that future is closer than we think. So, is Starship really ready to make the lunar dream a reality? Let's find out. Elon Musk has never been one to think small. His ventures, from revolutionizing electric cars with Tesla to disrupting the launch industry with SpaceX, have all followed the same philosophy: go big or go home. Now, that same mindset is being applied to something even grander: a return to the moon. But not just a brief return. Musk and SpaceX are setting their sights on something far more ambitious: a long-term, sustained human presence on the lunar surface. And leading the charge is none other than the Starship, SpaceX's most powerful and versatile spacecraft to date. To understand how SpaceX plans to pull this off, we need to revisit the incredible evolution of Starship. Initially conceived as the Big Falcon rocket or BFR, Starship has grown through various design iterations and high-altitude tests. Each version brought engineers one step closer to building a spacecraft capable of carrying up to 100 metric tons of cargo and more than 100 humans into space. Today it stands nearly 120 meters tall when stacked with its super-heavy booster, making it the tallest rocket ever built. But size isn't the only thing that sets Starship apart. The spacecraft is built for reusability, a key factor in reducing costs and increasing launch cadence. With rapid reusability, SpaceX envisions Starship as a space shuttle on steroids, one that can be launched, landed, refueled, and relaunched within days. For lunar missions, this makes a huge difference. The ability to send multiple Starships with cargo, crew, and infrastructure components, at a relatively low cost, transforms lunar exploration from a logistical nightmare into a manageable operation. NASA has taken notice. In fact, SpaceX's lunar variant of Starship was selected as the human landing system for NASA's Artemis program, a historic mission that aims to land the next American astronauts, including the first woman and first person of color, on the moon by 2025. That lunar version of Starship will differ slightly from its Earth-launching sibling. It will have no aerodynamic flaps or heat shield, since it won't return to Earth, and instead be optimized for operating in the vacuum of space and lunar gravity. But the challenges are far from over. Landing a vehicle the size of Starship on the moon is no small feat. Unlike Earth, the moon has no atmosphere, which means Starship can't use aerodynamic surfaces for maneuvering or slowing down. Everything must be done using rocket thrust. This brings in complex challenges around guidance, navigation, and control. The engine burns need to be precise, and the landing must be gentle enough to avoid kicking up too much lunar dust, which could obscure sensors or damage nearby equipment. There's also the issue of fuel. Starship will need to be refueled in orbit before it can head to the moon. This introduces an entirely new logistical puzzle: launching multiple tankers, transferring cryogenic fuel in the microgravity of space, and ensuring that all parts of this pipeline work flawlessly. SpaceX is actively developing orbital refueling capabilities, but it remains one of the most critical milestones they must achieve before lunar landings become reality. Once Starship makes it to the moon, its mission isn't just about exploration. It's about establishing a foundation. SpaceX's long-term vision includes constructing a sustainable lunar base. This would serve not only as a platform for scientific research but also as a launch pad for deeper space missions, including Mars. The moon, with its weaker gravity and proximity to Earth, is the perfect testbed. Resources like water ice can potentially be harvested and converted into fuel. Structures can be 3D printed using lunar regolith. Solar power can be harnessed continuously from poles where sunlight is nearly constant. This lunar base would be more than just tents and habitats. SpaceX envisions a complex with pressurized modules, landing pads, power stations, and possibly even greenhouses. Life support systems would need to be fully autonomous, managing oxygen, water, and waste with minimal resupply. Robots and autonomous rovers would play a crucial role in construction and maintenance. The idea is to create a thriving outpost where humans can live and work for extended periods. But none of this will happen without testing, and SpaceX is no stranger to iterating rapidly. Every Starship prototype test brings them closer to a functioning lunar variant. The company is also working closely with NASA to ensure that their systems meet the rigorous safety and reliability standards needed for crewed missions. The first lunar Starship landing, part of Artemis 3, is expected to carry 2 astronauts to the surface for a short mission. But the real test will be what comes after, when missions become more frequent, longer in duration, and increasingly independent from Earth. We can't ignore the broader implications here. A successful lunar mission by SpaceX would mark a major turning point in human space exploration. It would signal a shift from purely government-led initiatives to private-public partnerships, where companies like SpaceX can take the lead in designing, building, and operating complex space systems. This not only speeds up development but also spreads the costs and risks across multiple stakeholders. Moreover, it paves the way for a lunar economy. Once infrastructure is in place, the moon becomes a hub for science, industry, and perhaps even tourism. Imagine researchers studying cosmic rays or the lunar crust from state-of-the-art labs on the surface. Imagine companies mining rare elements or manufacturing components in lunar gravity. Imagine tourists taking a trip around the moon aboard a future version of Starship, gazing at Earthrise from a private viewport. Of course, many hurdles remain. International cooperation will be crucial, as will clear regulations on resource extraction and territory usage. Space traffic management will become increasingly important as more missions head to the moon. Environmental concerns, even in space, can't be ignored. The goal must be sustainable development, not a reckless race that pollutes or depletes our celestial neighbor. But if any company has shown the grit and vision to pull this off, it's SpaceX. From launching the most powerful operational rocket to landing boosters on floating platforms, they've continuously pushed the boundaries of what's possible. Now they're aiming even higher, or perhaps we should say aiming closer at our nearest neighbor. So, is Starship really on track to land on the moon? All signs suggest it's not a matter of if, but when. The coming years will be critical. Each successful launch, each milestone in refueling, life support, and crew safety, brings us one step closer. The moon isn't just a destination. It's the next frontier. And SpaceX is determined to take us there. We now push deeper into the heart of SpaceX's plan to take humanity to the moon. In Part 1, we explored how the Starship evolved, what milestones it has already achieved, and the intense ambition behind Elon Musk's target to land on the moon by 2025. But now we're going to explore the real nuts and bolts of this historic lunar mission. The how, the why, and the incredible vision that goes far beyond just landing on the moon. Let's begin by understanding exactly what makes the moon so strategically important. For SpaceX, the moon is not just a destination, it's a proving ground. Unlike Mars, the moon is only 3 days away. It gives scientists, engineers, and astronauts the chance to practice interplanetary living in a relatively accessible environment. Building on the moon first allows SpaceX to experiment with life support systems, in-situ resource utilization, radiation shielding, and long-term crew sustainability before attempting a much more distant and risky mission to Mars. This is why NASA's Artemis program has chosen SpaceX's Starship to deliver astronauts to the moon for the first time in over half a century. The Human Landing System, HLS, version of Starship is being specifically designed to ferry astronauts from lunar orbit to the surface and back. This Starship doesn't need the heat shield or flaps used for Earth re-entry. Instead, it's optimized for operation in the vacuum of space and the low-gravity environment of the moon. But landing on the moon is just the first step. The next challenge is staying there. And this is where things get both exciting and complex. A sustainable lunar base needs many critical systems working in harmony: reliable power sources, efficient habitats, protection from radiation, and a steady supply of life support materials like oxygen and water. SpaceX plans to use the moon's south pole, a region believed to contain water ice in permanently shadowed craters. If that ice can be extracted, it could provide drinking water, breathable air, and even rocket fuel, by splitting the water into hydrogen and oxygen. To make this vision possible, SpaceX envisions regular Starship launches delivering not just astronauts, but tons of cargo, habitat modules, solar panels, rovers, life support systems, and more. With its enormous payload capacity, up to 100 metric tons in its reusable version, Starship can deliver entire base modules in one trip. Compared to previous missions that relied on assembling small parts in space, this is a revolutionary leap in logistics. But the technical challenges don't stop there. Landing a massive spacecraft on the moon's surface without an atmosphere is no small feat. There's no air to slow the descent, which means rockets must perform all the work. And the moon's surface is extremely dusty and uneven. High-speed rocket exhaust can kick up clouds of abrasive lunar regolith that could damage nearby equipment. SpaceX will need to design landing pads, shields, or other mitigation systems to prevent this from becoming a hazard. Meanwhile, the conditions on the moon are brutal. With no atmosphere, there's no protection from radiation or micrometeoroid impacts. Daytime temperatures can soar to 127 degrees Celsius (260 degrees Fahrenheit), and nighttime temperatures can plummet to -173 degrees Celsius (-280 degrees Fahrenheit). Any lunar base will need to be heavily insulated, possibly even buried under lunar soil for protection. Some ideas include inflatable habitats covered in regolith, or 3D printed shelters made from moon dust itself. One of the key enablers of long-term lunar living is energy. Solar power is the most practical option, but lunar nights last 14 Earth days, which complicates energy storage. SpaceX, along with NASA and other partners, will need to develop high-capacity batteries or perhaps even small nuclear reactors to ensure continuous power during these extended nights. Communication infrastructure is another priority. Starship missions to the moon will require a constant link to Earth. That means setting up a lunar communication network, possibly using satellites in lunar orbit or relay towers on the surface. This infrastructure will not only help coordinate Starship landings but also support scientific operations and live communications with astronauts. Let's talk about the human experience. Living on the moon will be like nothing humanity has ever done. Astronauts will be confined in tight quarters, far from home, surrounded by barren landscapes. That can take a toll on mental health. SpaceX and NASA will need to design living quarters that support not just survival but psychological well-being. Think private sleeping pods, communal dining areas, entertainment systems, and even windows to view Earth from afar. Another exciting aspect is the science. The moon holds a wealth of untapped knowledge. Studying its geology can reveal clues about the early solar system. Astronomers want to place radio telescopes on the far side of the moon, shielded from Earth's radio noise. And of course, if we can extract resources from the moon, like rare metals or oxygen-bearing minerals, it could jumpstart an entirely new space economy. Now let's shift gears and talk about the rocket science. How does Starship get to the moon in the first place? First, a super heavy booster lifts Starship into Earth orbit. From there, the spacecraft needs to be refueled in space. SpaceX plans to launch multiple tanker Starships to deliver propellant to a waiting Starship in orbit. This orbital refueling is critical. It allows Starship to carry enough fuel to reach lunar orbit, land, and return. Once in lunar orbit, Starship HLS will rendezvous with NASA's Orion capsule and transfer the crew. Then it will descend to the moon's surface using its powerful Raptor engines. After the mission is complete, Starship will launch back into lunar orbit and reunite with Orion, which returns the crew to Earth. Later versions of Starship may be capable of Earth return as well, completing the entire round-trip journey independently. One of the most inspiring aspects of this plan is how SpaceX is rewriting the rules of space exploration. In the past, a single moon mission cost billions and took years of preparation. SpaceX wants to make moon travel routine. With a fully reusable launch system and rapid launch cadence, the company envisions dozens of missions per year, carrying not just astronauts but tourists, scientists, and entrepreneurs. Speaking of tourism, yes, SpaceX plans to offer seats to private citizens. Billionaire Yusaku Maezawa has already booked a flight around the moon on Starship with a group of artists, musicians, and creators. This kind of mission will help pave the way for public engagement and private investment in lunar development. Looking even further ahead, a lunar base will serve as a launch pad for the next great leap, Mars. Technologies tested on the moon, like oxygen extraction, habitat construction, and closed-loop life support, can be directly applied to Martian missions. And psychologically, building a permanent outpost on another world will prove that humanity is ready to become a multi-planet species. But let's not pretend it will be easy. There are still major hurdles to overcome. Starship hasn't yet completed an orbital mission. Refueling in space remains unproven. Lunar landing systems need more testing. And political, budgetary, and logistical challenges remain. But if any company can overcome these odds, it's SpaceX. Their rapid prototyping, willingness to accept risk, and sheer determination have already achieved what many thought impossible. This is more than a mission. It's a turning point. If Starship can land humans on the moon, establish a base, and do it affordably and reliably, it will change the future of space forever. Moon bases will become staging areas for science, commerce, and exploration. The moon will no longer be a faraway goal, but a stepping stone to the stars. In conclusion, SpaceX's Starship lunar mission is not just about touching down on the moon, it's about building a foundation for everything that comes next. From sustainable bases to interplanetary travel, this is the beginning of a new chapter in human history. It's bold, it's ambitious, and it's happening faster than most people realize. So the next time someone asks if we're really going back to the moon, you can confidently say, not only are we going back, we're staying. But there's another dimension to all of this that people often overlook: the human factor. We're not just talking about technology or hardware anymore. We're talking about real people leaving Earth behind, possibly for months at a time, heading to a barren, lifeless rock over 200,000 miles away. The moon has no atmosphere, no breathable air, no weather systems. It's essentially a giant, exposed rock bathed in deadly solar radiation and freezing cold shadows. Living there, even temporarily, will demand a level of mental and emotional resilience that we can barely test here on Earth. Isolation, tight quarters, reliance on systems that can't fail. That's a recipe for stress even in the best-case scenarios. That's why psychological preparation is becoming just as critical as physical training for these missions. SpaceX isn't just building rockets. They're helping pioneer a new kind of human adaptability. What happens when you're stuck with the same handful of people for weeks or months in a confined metal habitat on the moon? What happens when something breaks, not just outside but inside, emotionally? This is where the future of space travel depends not just on science, but on empathy, cooperation, and mental endurance. It's one thing to survive the trip. It's another to thrive in a place that's actively trying to kill you every second. And yet, despite these staggering risks, the dream pushes forward. Because the moon isn't just a destination, it's a mirror. It reflects what we're capable of as a species. It tests the limits of our imagination, our courage, and our technology. If we can live there, even temporarily, we prove that we can become something more than a single-planet species. That we can endure, expand, and evolve. Starship's lunar mission is not just a voyage across space. It's a statement. A declaration that we are not afraid to explore, to challenge the impossible, to step beyond what's comfortable. That's what makes this mission so powerful. Not just the fuel, the metal, the software, but the raw human will to reach for more.